today to see the doctoral presentation, defense dissertation by Amir Aly. The title is Towards an Interactive Human-Robot Relationship, Developing a Customized Robot's Behavior to Humans Profile. So this is for the Doctor of Philosophy at ENSTA-ParisTech. So today, Amir will present his work for 45 minutes, and then there will be questions by the jury that is made up of the two reviewers or rapporteurs, Jean-Claude Martin from University of Paris, Ons, France, Rashid Alani, who is here with us by Skype from LAS in Toulouse, and then examiner Angelo Cangelosi, who just arrived from Plymouth, myself, Peter Ford-Dominy from INSERM Lyon in France, examinator Ginevra Castellano, no, did I say that okay? Ginevra Castellano from the associated both with University of Birmingham and Uppsala, and examinator Nicola Bellotto from University of Lincoln in England, and of course the supervisor and director Adriana Fabrice from ENSTA-ParisTech. So please proceed with your defense.
Thanks for you all to be present today with me in my Ph.D. dissertation defense, which is about towards an interactive human-robot relationship, developing a customized robot behavior to humans profile. In the first part of my PhD, I was concerned by considering humans profile in terms of emotion personality. The motivation for considering emotion, number one, is a fuzzy and evolutionary nature of emotion. Emotions, like all categories, they exist in our world, but with fuzzy borders, which means in order to categorize it, we need an algorithm that can consider for this fuzziness of borders of emotion classes and the evolutionary nature of emotion. Emotions, like can exist in primary emotion or basic emotion, but with time they can convolute, they can evolve and compose complex emotions. So we need an algorithm also that can consider for this evolutionary. Suppose, for example, a system that's trained on a sequence of primary emotions, suddenly a new complex emotion exists in the system. If the system is not trained to recognize the existence of the new existent complex emotion, the system will attribute this new emotion to the nearest existing primary emotion in the system and will attribute its action to it. And this can consequently generate an inappropriate behavior to the context of the action. So in order to avoid that, which is the case of the most traditional emotion recognition algorithm, we need a new intelligent algorithm that can consider for all these aspects. That's why we developed a new online fuzzy-based algorithm for emotion. Concerning personality, the motivation for considering it is a long-term effect of personality on the verbal and non-verbal behavior. And number two is to increase the naturalness of interaction between a human and robot. The solution is to adapt the generated behavior of robot to the extraversion personality trait of human, as it is the most personality trait related to the generated social behavior. For the generation part in this PhD, I was concerned by generating synchronized speech and gestures to human personality extraversion level, and generating synchronous speech, gesture, and facial expression based on human elicited emotion, and we will speak about that in details. In this work, the generated body language is varying between metaphoric gesture, iconic gesture, gait gesture, posture shift. In this architecture, we summarize the phases that I have developed in my PhD. It starts by capturing the audio and the video level, and goes to the first phase, which is online detecting emotion based on the video input. After that, we have the emotion detected, and we have a decision, new action to be synthesized. This is the importance of the fuzzy system. So the system will detect. Now we have a new action to be synthesized corresponding to the new born emotion in the system. It goes to the last step, which is concerned by generating multimodal behavior. And this is actually, for the moment, the future scope for the current research. Phase number two is about detecting humans' personality and generating adaptive behavior to it. And number three, generating adaptive gestures to humans' prosody, and also we are interested to associate that with facial expression, so that all this multimodal behavior will be modelized on the problem. So we have Ali's problem in this work. The first part is an online fuzzy-based approach for human emotion detection. The objective of this part is to detect whether a new emotion is belonging to one of the existing emotion clusters. so that it can take its action, or it constitutes a new emotion cluster that requires a new model of behavior to be synchronized. The first step in this approach is to adopt one of the emotion models that can consider for the evolutionarity of emotion. The problem is that most of the existing emotion models, like Izzard, Aikman, and Tompkins, are considering for the primary and fundamental emotions only. We need another emotion model, which is Blachik model here, who is the only model that currently most widely used emotional model that consider for the evolutionarity of emotion. In 1991, he developed a 3D circumflex field for emotion that considers the evolution of nature. The 3D is the intensity. It means that here, for example, this level of viscosity is higher than this level, is higher than this level. The similarity means that all the emotions within one circle have similar intensity. Here they are the highest intensity, and here lower intensity, and after that lower intensity. And the polarity means that joy and sadness, for example, they are existing in opposing branches, and so they have different emotions. The combinatory nature of this model, first of all, the primary combinations that we can have between anticipation and joy, we can have opposites. We can have secondary and tertiary emotion combinations, which are the mixture of two non-adjacent primary emotions with one primary emotion. In between, like between anger and joy, we can have pride. And between, or two primary emotions in between, like between fear and disgust, we can have the shame. The first step before going to the online generation of emotion is to choose the most distinctive vocal features that can distinguish between emotion classes. And for that purpose, we have generated an offline system that can, based on three databases, GES, GDs, and ACS. This is a German database, this is a Swiss database, and this is a Spanish database, that are considering for the primary and the complex emotions stated in the Blachik model. We have stated 10 vocal features like the pitch, and we have used statistic measurements of the pitch, mean, maximum, etc., and the energy and their statistic measurements. We wanted to see if there will be enough, distinctive enough to distinguish between emotion classes or not. So here we have, when we mix all the three databases together, and the blank spaces here are emotions that are not existing in each emotion database. So we have compensated that by mixing all of them together. We find that the scores are varying between 80 to 96%. The important part, that which actually are highly recognizable scores, the important part here is to define an average confidence recognition score, which here in this case is a score greater than 80%. And this score is used as a threshold for our online system generation. The first step in the online system generation is to use a subtractive cluster. The importance of detecting cluster centers is to calculate the antecedent parameters, which are the rules of the fuzzy model. So, cluster centers are the most descriptive points within the data space. So they are the points that have the most, or the highest groupings of data points around. So here, we calculate the potential, which is a translation of the density of these points, which is related in the relation number one, is equation number one, related to the distances, difference between the distances between points. So the first cluster center in the model is the model that has the highest potential calculated from the equation. After that, when we calculate the second, the third, the fourth cluster centers, we calculate them with respect to the first calculated, or the last calculated detected center. So here, for example, if you will calculate the second cluster center, it will be calculated and subtracted with a part called x. This part is a function of the potential of the last detected center. So in case of the second cluster center, this potential here will be the potential of the first cluster center. The idea of this subtraction is to have cluster centers in the data space highly spaced, distributed, not near to each other. Concerning the criteria of accepting or refusing centers, if the potential calculated potential is greater than 0.5, with the upper, which is the upper threshold, the center is accepted. If it's less than 0.15, the center is rejected, and if it is between 0.15 and 0.5, a new rule will be applied for accepting all cluster centers. After detecting the rule, which are the blue points here, we can now set up for the fuzzy model for detecting the function. So here we find a typical view for the Tajik-Soghian model. It started by the input vector, which are the characteristics that we have validated from the offline system, the pitch and energy, minimum, maximum, etc., the 10 input vectors. After After that, we go make the inference with the input membership functions. After that, we make the mapping to the rules. After that, to the output membership function and to define out.